just the basics of algebraic expressions, right? We need to know how to identify these pieces of an algebraic expression versus an equation. And from there, we should be able to do everything else, right? Because we have to keep referring back to this vocabulary when we have expressions or equations. So we need to know what a variable is, what a constant is, what a coefficient is. With that in mind, we should be able to do kind of everything else. All right. Let me just keep moving here down this line. Just some more definitions in here. What a numerical expression is, it means that there's no variable, right? It becomes algebraic when we add a variable. Okay. And you notice here along the top, I have addition, subtraction, multiplication, and division. And then there are words or phrases that are associated with that, right? So if I'm adding, obviously it's going to say added to, but it's also going to say sum, plus, or more than. Subtraction is difference, take away, less than, right? Multiplied is product or groups of, and division is divided or quotient of, just so we have a better understanding of those vocabulary words, just in case and when they come up. So that's also included for reference. Okay. So what we're going to do here in this part, we're actually going to write each expression as either a numerical or algebraic expression. Just make sure we can go from words to expressions, because this is something that you might be tasked to do this on your test. So just want to make sure that you guys are able to read an expression in words and turn it into a numerical or algebraic expression. So we'll start off with a nice easy one. Number one, it says 279 minus 125. That's just gonna look like this, right? That's the algebraic expression of that. The numerical expression of that, excuse me. What do we do for 2? What is the product of 15 and x? What does that look like? The product of 15 and x?
Are we dividing?
What does product mean?
It's multiplying?
Yeah, product is multiplication, right? So it's going to be 15x. All right, what about, I'm going to just jump around a little bit. What about number 6? It says 8 more than x. How do we represent that? 8 more.
8 plus x or x plus 8.
Yeah, either way is going to be fine, right? Because addition is associative. We can do it forward or backwards. Yep, so that works. Good. Number 4, m multiplied by 67.
M67.
So it's always going to be 67m, right? We're always going to write the number before the variable.
So the coefficient comes first always.
Always, always, always. Yes. Okay, and then let's do number 5. 15 divided by d.
15 over d, or?
Yep, perfect. That works. Okay. Let's try it the other way. Let's turn some phrases or some expressions into phrases. All right, so let's try number 1. It says, it looks at r plus 87.
Mm-hmm. I can let somebody else go.
Stacy, you want to try it? R plus 87? So it would just be r added to 87. We can say something like that. We can also say the sum of r and 87. And I can barely hear you. You sound super far away.
Well, I'm right at the computer. I just needed to minimize your screen and go back to my regular screen.
Okay, I got you now. Now I can hear you. Yep.
So
Okay.
for the second one, I would do 345 multiplied by 196.
Good. Multiplied by 196. Sorry, my thing is off to the side here. Okay. Yep, that works. We can also say the product of, right? The product of those two numbers. All right, good. Just wanted to make sure we got that. I think we can move forward, right? There are some links in this PDF that I hope still work, but yes, they do. So like if there is a section that you need more work with, I have included the Khan Academy link that'll hopefully take you directly to that page as well. Okay, all right, let's keep going. All right, so when we're evaluating expressions, we of course use the order of operations, right? And when we evaluate an expression, we're usually at first just substituting our numbers in whatever value we're given. We're using that operation, that expression, or replacing the variables with a number, and then we're doing the operations as indicated, right? When we're working through this, we just have to follow along in the process. So we already know it, we're going to work through it. So it says we're going to evaluate each expression when A is equal to 8, B is equal to 2, C is 4, and D is 3. So in my first expression, I have 2A minus 3B. So I'm going to replace my A with 8 and my B with 2. So it becomes 2 times 8 minus 3 times 2. Right, and I just evaluate each of these. I'm going to have 16 minus 6 to give me 10. Right.
So, Mr. G, do you have any tips for when we're taking the virtual calculator? Because I do a lot of my math using scratch paper, and it's going to be a little difficult.
So you have to remember that half of your test, you're not going to have the calculator, right? Okay. So you're gonna have to do scratch paper for half of the test anyway. So that's one thing. But when you do have your virtual calculator, and you can also practice. So like there is a site. Let me grab it and I'll put it in the chat for you. There's a site that has a way for you to download a electronic version of that calculator to your computer. So you can actually even practice with the GED calculator online. Okay. All right, so I'm going to put it in the chat. This link, if you follow this link that I'm going to add eventually, you want to click on the first link that shows up, and that actually will be the emulator for the TI-30X calculator. And you guys will be able to use that to kind of give yourself a little bit more practice using the electronic version of your calculator. And one of the other things, and I think I'll just go ahead and add some of this information also to your course. It is going to be important to kind of practice with the calculator, doing certain things like maybe like fractions and other things. That might be helpful. And I will include, I'm going to include it right now. I'm going to add it to that folder because I already have some stuff on there. I'll just put a folder in your class called calculator use. And that it will actually just cover how to use your calculator. Okay. And go back to that course now. And take here. Okay. All right, so in the GED Prep Math course, I did add the calculator use folder, and I'll just put it, because everything I have it kind of in alphabetical order, so I'll just put it at the top here. But in the calculator use folder, it has that link that I just added to the chat to download the electronic version of the calculator. And it also just has some basic information on how to use your calculator, and then how do you do more advanced things, like how to use exponents and roots, because those are the kind of things that will save you a lot of time. Is if you're more able to use your calculator to put in exponents and the square roots and things like that, that's going to help you a lot. And then there's the toggle key function, which actually turns decimals into fractions and fractions into decimals just by pressing it. So that toggle key is actually really helpful as well. All right, and that toggle key is the key that is in the corner right above the enter key, right? So that toggle key is very helpful. It should be a key that you're more familiar with. So there's a video on how to use it and what it does, okay? So I definitely recommend before your test that you navigate through here and learn a little bit more about your calculator, okay? Because that calculator is gonna be very helpful to you. But yes, scratch paper is what you're gonna have to use for half of your test. When you got your packet from Miss Butler, she should have included like a whiteboard.
Mhm.
So the whiteboard with marker is actually gonna be better for you to use when you're doing your.
So we're allowed to use whiteboard.
Yes, you're allowed. Yes,
All right.
yes.
All right, I should be fine. That will be fine.
Yeah, use your whiteboard for calculations, because using scratch paper, you're gonna just like be like, where did I put that? And you're gonna be looking for extra space on that like one sheet of paper.
Mhm.
But the whiteboard you can just erase, and I think it's neater and easier. So definitely use your whiteboard on the test. Yeah. Okay. But that was a good question though. All right, let's go back to these notes. Right. All right. And are you guys comfortable evaluating expressions in that way, in the way that I just described, where you're just plugging it in through substitution and doing
Yes.
that? You guys are both good with that? Okay, great. So as long as you're comfortable with that substitution, you don't have to worry about it. But if you do need more help, there's this practice, as well as the Khan Academy link for more substitution practice. All right, great. All right, like terms. This is kind of a, seemingly an easy thing, but there are some hiccups that normally come about when we're combining like terms. That usually comes about when we are looking at our roots and multiple variables, which is something I think that was mentioned earlier. So when we look at equations like these down here, right, and we're going to try to make sure that we are simplifying our expressions, remember that we can only simplify expressions that are exactly the same, right? So we cannot simplify terms that are exactly the same. So in this case, for number one, obviously the only two things that we can combine together are the 4 and the 7, right? Because this 2 is hooked up with that n. And so we have 11 plus 2n, right? And we can leave that like that, or we should write it in the way where that's more acceptable, is to make sure that you put your constant at the end and your anything with a variable before that, right? Where it gets messy is down here, like with number 6. So there's sometimes confusions with the square and not squares. Make sure that you're only combining things that are squared with things that are squared and the same letter, and not combining unsquared items with squared items, right? So for instance,
Okay.
with number 6, you want to make sure that you can put the 8q and the negative 7q together, right? But the q squared is separate. And then you can also put together the r squared items, the two r squared, the minus r, the negative 4 and the plus 10. So when you do combine these, you're going to end up with just q right? When you combine these two, you're going to end up with 6r squared, right? And you bring down the 5q squared. And then of course you have to rearrange it in order. And when you put it in order, you're going to have 5q squared plus 6r squared plus q. And the
All
reason
right,
that
so when
the
you're
reason-
adding squared numbers with each other, it doesn't change the exponent.
absolutely not. No, right. When we're
Okay.
adding, yeah, when we're adding, we're not worried about changing anything. When we are multiplying, it doesn't matter what the term looks like. We can combine anything together with anything else through multiplication. But when we're just adding and we're combining through adding, we can only add them if they're the exact same, and then we don't change anything about that term, right? The only thing that brought these two terms together were the fact that they were both r squared, right? That's the only thing that brought them together. So we can't change what brought them together, if that makes sense, right?
Mhm.
The only thing that unites them must be the thing that we keep about them. Okay. All right, so let's combine number 5. I'm going to let you guys combine number 5 for me. What are we going to end up with? So you guys can work it out. Let's give you like a few seconds to work it out and then tell me what it is combined.
I have my answer.
Okay. So you have your answer as well?
Yes.
Okay. All right. What do we got?
I got 9E plus 5EF plus 2G plus 4.
I have the same exact answer.
Very good. All right. Good. You guys, even without me telling you, you've put it in alphabetical order, and that's good too. You should always try to put it in alphabetical order and also in degree order. So like in number 6, I started off with the q squared, right? Because q comes before r, but I can't just list the q after the q squared because this r squared is a higher degree than the q, right? So you always want to make sure you put it in alphabetical and degree order, right? So 4, exponent of 4, exponent of 3, exponent of 2, degree order, and alphabetical order. Okay, good. That worked out well. All right. Any concerns about combining like terms?
No.
Great. Okay. All right. And then the last thing here is when we're working with our distributive property and we're trying to make equivalent expressions. All right. So here the idea is I have two expressions that are going to give me the exact same result, right? For number 1, for instance, very easy. We have 4 plus 1, which of course equals 5, right? So what number would I need to replace this box with to also make the other side equal 5?
3.
3, right? Very simple. The same idea is when we're working with our distributive property. Like if we look at number 6, we have CW minus D. And then on the left here, we have C times W minus what? What would need to be in that box to make this side the same as that side?
D.
B, right? Very simple, very straightforward, but we do have to recognize the skill that's being taught here is using our distributive property, right? We have to remember that when we distribute, right? Like if I have a 4 outside of this parentheses, I have to apply it to both of the things that are inside the parentheses. Sometimes that's going to result in a multiplication. So like this needs to be 3. So get 4 times negative 3 gives me a negative 12. And sometimes when I'm multiplying a variable to a number to a variable, that I have to keep both parts, right? That sometimes gets lost. I just want to remind you all that when we're multiplying and distributing, right, we have to make sure that we're distributing accurately so that we get the -12 and the 4y. I don't want us to end up with just y minus 12, which happens very often. People forget to multiply that 4 to the variable to get the 4y. I see that a lot. So just when we're keeping up with your distributive property, make sure you remember that, right? That you need to apply both, okay? The other side of that is working in the reverse, right? So if I look at this example number here, down here with number 2, I have 6 times 10 plus 6 times 4. Obviously, both of these parts of my operation have 6 in them. So I can pull the 6 out and make it 10 plus 4. We very often don't work backwards in that way, but you need to be able to see it both ways, right? That you can distribute a 6 and you can pull a 6 out. Okay, so for instance, how that translates usually is with a situation like this. I have x squared plus x squared, x to the 4th plus x squared, right? And you're going to be asked to do something like simplify this expression. How do you simplify that? X to the 4th plus x squared.
Do you pull the x? Or no,
What do they both have in common?
they have exponents. So do you
Okay, they
change
both
the
have
exponent?
exponents. They both have exponents. They both have what else?
X.
They both have x, right? What is so we have 4 here and we have 2 here, right? Is 2, is 4 a multiple of 2?
Yes.
Yeah, right? So that means I should be able to pull x squared out of both of these. So what that means is that I should be able to pull out an x squared out of both parts of this to simplify it. So it'd be x squared times x squared is going to give me x to the 4th. And then x squared times 1 will give me x squared. All right, so when we're simplifying expressions, we're using our distributive property to pull out what we can that's similar in both parts or in both terms, okay? So whatever I can see in both terms is what I can pull out. So for instance, I'm going to keep going with this idea. If I have 2x squared plus 4x, what can I pull out of both of these terms?
Two.
You can pull out 2, good. What else? What else do they both do? Sorry?
X.
X, right? I can pull out 2 and I can pull out x out of both of them. So I pull out 2x. What do I need to multiply 2x by to get 2x squared?
4x.
So I'm trying to get 2x squared, right? I've already pulled out 2x. What do I have to
So
multiply?
2x.
I'd have to just multiply it by x.
Okay.
2x times x will give me 2x squared. What do I have to multiply 4x? What do I have to multiply 2x by to get 4x? 2x times what will give me 4x?
2.
2.
Okay, so
I think I heard you, but you were, again, a little far away. Yeah, so 2x times x plus 2 would give me 2x squared plus 4x. Okay, so yeah, so that's our distributive property. Let me see here, excuse me. Sorry. I should. Okay, so in your folder, there is an activity here to work on that a little bit as well. Let me clear this. So in that expressions, equations, and inequalities folder under lesson 1, there is a practice, there's a short little practice on the distributive property to kind of work through both ways of distributing and then also factoring things out, right? What we just did by pulling out what's common out of the two things is called factoring out. And so there is a little bit of work on that just so you guys can get more practice on that aspect of it. Okay, so we can also not only distribute, but go backwards, which is to factor out. Okay. All right, so that was just our introduction to expressions. And I hope that it seems like you guys were pretty good with those things. We have another lesson here on solving equations and then one on inequalities. But I did remember that there was a request to do some more advanced equations where we have multiple variables. So let me see if I can pull that up. All right, so okay, here. So we have systems of equations here. Is this kind of thing you were looking for? Like this or something different?
Something different, but we can do this too. Like I can.
This would be very different, but I'm not. So I wanna try to keep it in relatively the same vein of what you were looking for. But is there? Let me see.
So 2 variables before the equal sign is where I get tripped up. And like I just feel lost and like what am I supposed to do?
Okay. All right, yeah, let's look at these systems of equations. Maybe this will help clear up some of that. Okay, let's see. I'm going to start not with graphing, but with substitution. All right, so we have these systems of equations here. And when you solve a system of equations, you have a couple methods that you can use. Well, you have three methods. You can use graphing, elimination, or substitution to solve a system of equations. I'm going to demonstrate which is typically viewed as the easiest first, which is substitution. So you take one solution and you put it in as the answer to your other equation, and then you solve, right? So if we start here with example number 2, we have 2x plus 2y equals 10, and y equals 4x. So what we're going to do is take the solution that we already have and plug it into the other solution. So we're going to replace y with 4x. Okay, so we're going to have 2x plus 2 times 4x is equal to 10. And then we just solve. So we're going to take that 2 and just multiply it to the 4x. So it becomes 8x. So now we have 2x plus 8x equals 10. 2x plus 8x is going to give me 10 x's. So when I divide both sides by 10, my answer is that x is equal to 1, right? Now that I have my answer for one variable, I will very easily be able to find my answer for the other variable. I can plug this one into either one of these other two equations. Obviously, it's going to be easier to just plug it into this one. And I have y equals 4 times 1, which is just going to give me 4. So systems of equations I can solve using substitution, right? And that's that first method there. So that's how I got that answer. So you should be able to try this example here using that same method. So what's the answer for what's y and what's x on this side? Go ahead and solve that one.
I'm finished.
Okay. All right, what did you get?
So I got x equals x equals 1.
So when you got it to this point here, after you've plugged the 3x in, it should be 3x minus 12x, right? So that should have given you a negative 9x.
So it's -1. I thought I did it wrong.
Yeah. Okay, good. So -1. So that means it's also going to give you a negative answer for your y. So you get -3. Okay, so let's do example number 3, just to keep practicing with this mode of substitution, and we can do a couple elimination ones as well. Okay, so it's really easy to just use the one that already has it solved for one of the variables and just plug that variable back in normally, right? That's going to be the kind of easier way to look at it. But as you can see, actually in this first problem, I don't have a y, I only have x, right? So I can solve for x immediately just using this by simplifying it. So I have -4x minus x. So when I simplify, I just have -5x, right? Because -4x minus another x gives me -5x is equal to -19. I'm going to divide both sides by a -5. So that x is equal to 19/5. I'm just going to leave it as that fraction. That's going to make my life easier if I just leave it right now as that fraction. I don't need to simplify that. Okay. So that's what x is equal to. So to solve for y, I just replace my x. So I have 19/5 is equal to 2y plus 1. So I'm going to subtract 1 from each side. So I have 19/5 minus 1, right? I just want to make this into a fraction again to make this easier for myself. So it's going to be -5/5. Right, that's going to give me the fraction I'm looking for, the fraction of 1 that I'm looking for, but also negative. So it's -5/5. 19 minus 5. It's going to give me just 14/5 is equal to 2y. I'm going to divide both sides by 2. When I divide 14/5 by 2, right? So it's 14/5 divided. Oh, let me just undo this, sorry. Let me straighten up my. Okay. So I have 14/5 divided by 2. Remember, when we're working with fractions, we don't really do division, right? We skip, flip, and multiply. Guys, remember that? So I skip this first fraction, turn my division into multiplication, and I flip my second fraction. So instead of 2/1, it becomes 1/2, and I just multiply straight across, right? In this case, I can go ahead and divide out this 2 to give myself 7/5 as my fraction. So y is equal to 7/5. This one wasn't as fun as the first one. I don't like when I have to work with fractions, but so it is. It's fractions. Okay, what I want to do is I want to try this other one with you all. Will you try 3? We're going to do this one in a stepwise fashion where you guys are going to explain the steps to me just to see if we're getting it. Okay. So I'm going to erase here. And so we have these two equations. One says negative 2x minus 3y equals 12, and the other says x equals negative 3y minus 18. So where do I start?
I'm a little lost.
Okay. So whenever we are substituting, right, we want to try to replace or get rid of one of the variables and solve for the other variable. So the way to do that is to rearrange it so that you have an x equals or a y equals. In this case, I have x equals, right? It already tells me that x is equal to this, negative 3y minus 18. So when I substitute, I'm going to take this and replace the x in the other equation with this negative 3y minus 18. So I'm just going to rewrite this whole thing, but replace the x with only y so that I can now solve for y. Okay, so I'm going to do negative 2 times negative 3y minus 18 minus 3y is equal to 12. Okay, so in a substitution problem, I always want to get one of the variables by themselves. So get a variable alone. In this case, it's given to you. Right, we already have x equals. So we're going to take that x equals and replace what, because we have a value for x, right? That's essentially telling us that this is what x, the value of x is. We don't really know what that value is, but it's already solved it nice and neatly for us. So we're going to take that value and plug it into the other operation so we can try to find an actual number value for one of our variables. All right, so in order to solve this, I now have to distribute my negative 2 to both of the things inside the parentheses. So what's negative 2 times negative 3?
6.
Great.
6y.
So I'm going to have.
All right, I think I solved it.
Okay, great. What'd you get?
I got y equals 3.333333333.
3. Okay, good.
Do you want me to go over the steps I took?
Well, I was gonna, no, I think, let's see, 3y, 36 minus 36. Yes, because I'm coming up with a different answer.
Oh, I didn't distribute the 2 to the 18.
Okay. All right, because when I combine the 6y and the 3y, I'm going to end up with 3y plus 36 is equal to 12. When I subtract the 36 from both sides, I'm going to get negative 24. 3y is equal to negative 24. When I divide both sides by 3, I'm going to get y is equal to negative 8. Once you have one variable, you use it to solve the other variable. So now I'm going to replace the y in that second equation, or in the first, doesn't matter, but it's going to be easier in the second equation if I replace the y and now solve for x. So we're going to have x is equal to negative 3 times negative 8 minus 18. Okay, so that means x is going to be equal to 24 minus 18, which is 6. So x equals 6 and y equals -8. I told you, that distribution, you got to remember to do both parts.
Mm-hmm.
I thought I was fooling. And then you saw it happen.
Yep.
You got to do it to both parts. It happens. I've seen it too many times. Like you trucking
I
along.
think I gotta remember to draw arrows actually. Like
Yeah.
I have to draw arrows to remember.
Just do it. I do it all the time. Wait, did I do all of these steps? Right? And that's actually, look, if you do that, then it's a good way for you to look back and be like, what happened? Oh, there, I didn't see, I didn't, right here. It's right there. I didn't do that step. Okay, should we do another substitution example or should we move on to elimination? I prefer elimination. I think elimination is easier, but I may be biased. Elimination?
Sure. If it's easiest.
I don't think it's easier. I just like it. I think it's actually probably a little more complicated, but it's necessary to learn. Okay, some equations are not going to be as easy to substitute as others. And then you have to do what's known as the process of elimination. So I'm going to move down to the elimination section. All right. I don't want to start with a super easy example. So we'll start here with example number 2. All right, so the idea behind elimination is similar to substitution, of course. We want to get rid of one of the variables, right? The only difference is here, what you're trying to do to get rid of that variable is you have to manipulate the whole equation. And then you want to add the two equations together. So right now I have 6x minus 2y is equal to 4. And 4x minus 2y is equal to 2. If I were to add these two equations together, I would not be able to eliminate either of the variables, right? Because when they add together, none of them will equal to 0. So what I'd have to do is manipulate one of these equations to make it so that when I add the two equations together, I get rid of one of the variables. I'm going to do that by working with my y's because I have -2y in both cases. So if I multiply either one of these equations by -1, it'll change my -2y into a +2y, which is the opposite of what I have in the other equation, thereby eliminating that variable, right? So this is why it's called elimination, right? I'm eliminating a variable. So to do that, I'm going to just choose, again, it doesn't matter which one, but I'm going to choose this first equation and I'm going to multiply the entire equation by -1. I'm multiplying the whole thing by -1. So what's 6x times -1? What does that become?
-6x.
-6x. My -2y becomes a +2y and my +4 becomes a -4. Okay. So now that I have this, I'm going to go ahead and add to it my other equation. And when I add -6x plus 4x, how many x's do I have left?
2.
I have -2 x's, right?
Okay.
Okay. My y's are eliminated. They're gone. And now I have -4 plus 2, which gives me how many? -4 plus -4 plus 2 is 2, right? Good.
Yes.
-2.
-2. So then you have -2x divided by -2, and then you have -2 divided by -2, which gives you x equals -1.
Nope. -2 divided by -2.
It's just 1.
Yep.
1.
Okay. So now that you have x is equal to 1, again, you choose either equation and you plug the 1 back in. Make sure it's the original equation and not the manipulated one. But you plug 1 back in to find your answer for y. So now we have 4 times 1 minus 2y is equal to 2. 4 minus 2y is equal to 2. Subtract 4 from both sides. Negative 2y is equal to negative 2. So we find that y is also equal to 1. We divide both sides by negative 2. We see that y is also equal to 1, right? Is that true? Well, we can check it by plugging these numbers into the original, so one of the other equations again, just to check it. So we have 6 times 1 minus 2 times 1 is equal to 4. Is that true? Well, 6 times 1 is 6. 2 times 1 is 2. So 6 minus 2 does in fact equal 4.
Yeah.
So you can always check it by using them in the other equation that you didn't use. Okay.
Mhm.
So that's elimination. I love elimination. I think it's fun. I don't know why. I'm a crazy math teacher. That's the only explanation I can think of. But so you guys try it. I want you to try it with this number 2 here, just to see what you, I know you only saw one example, but I still want you to see if you can try it and get the answer. So remember, I had to multiply one of these equations by -1 to eliminate the variable. You might have to do the same thing in this one.
I have my answer.
Okay. All right, tell me what you did as your first step.
I multiplied the first equation by -1,
Okay,
which gave me -3x minus 4y equals -10.
good.
Then I added the second equation, which was 3x
Mhm,
plus 2y equals 8.
mhm,
The 3x zeroes out.
good.
Then you get -2y equals -2.
Good.
Then you divide -2y by 2, and then you divide -2 by -2,
Mhm.
which gives you a +1.
Okay, great. All right, and what did you get for your value for x?
Ooh, need to solve for it. I need to solve for it.
Uh-huh. You're not done till you have both variables.
I think x equals 2, I think.
Yep. Good. All right. So substitution and elimination, right? Those are your first two ways to solve a system of equations. Basically, if you are looking at your system and see examples like you have here, where they are similar enough, where if you use elimination, they can be easily eliminated, you're going to want to choose elimination. I think elimination just works easier. It's better than trying to substitute sometimes because you're working with too many numbers when you substitute. All right, so always try to go for elimination first if you can. and then kind of say substitution for those ones that are not obvious and like not easy enough to be manipulated to substitute?
Mr. G, can we solve for x? I'm getting stuck.
Sure. So when you plugged in the 1, right?
Mhm.
You got
Yeah.
3x plus 2 times 1 is equal to 8. If you use the second equation, did you use the second equation? Because that's what I did.
I didn't plug in.
Okay, yeah, you always have to plug in the 1. Yeah. So now that you have your value for y, you gotta plug it in. That's how
Okay.
you solve for x. Yeah.
3x.
So you have 3x plus 2 is equal to 8, and then you just solve for the x. You subtract 2
Alright.
from both sides, and you get x equals 2. Yeah. Good. All right, so elimination should be a preferred method, then substitution. And then the last option, or not last, but one of the other ways to do it, to solve a system of equations, is to use graphing. So you can solve a system of equations by graphing. And I will show you that right now. Okay, so we have x plus y equals 12 and x minus y equals 6. Your first step when you're solving systems of equations using graphing is you have to rewrite your equations, right, into slope-intercept form, or y equals mx plus b. So rewrite your equations. As y equals mx plus b. So right now, instead of x plus y equals 12, I just have to subtract x from both sides. I'm going to get y is equal to negative x plus 12. And in this case over here, I have x minus y equals 6. I'm going to subtract x from both sides. And then I also have this negative y, so I have to divide everything by a negative 1. So it's going to end up being y is equal to x minus 6. Okay, now that you have your two equations, that's your first step is to rewrite them. Now that you have your two equations, you're going to use your intercept and your slope to graph the lines. All right, so use intercept and slope to graph the lines. So remember that your y-intercept is always at the end of that y equals mx plus b equation. That's why you wrote it like that, so that you knew what the y-intercept was, right? This is your y-intercept. And then of course your slope is going to be the number that appears before your x. So in this case, my slope is going to be just negative 1. And here my slope is 1, right? Because if there's no number, that's what my slope is. And then I have my intercept. Excuse me, I should rewrite this because my intercept is not 6, it is negative 6, right? Make sure you include the symbol, or the symbol before your number for your intercept. When you graph the two lines, you'll be able to see where they intersect, and that is the solution to your system of equations.
Can you show us how to graph it, where to graph it?
I'm going to graph it. Yeah, I just have to move my screen down. So I'm going to lose my equations, but I'll rewrite them because my graph is not on the same thing. All right, so negative x plus 12 and x minus 6. So y equals negative x plus 12, and y equals x minus 6. Those are my two equations. So I'm going to graph them. I'm going to graph this first one first. I'm actually going to make this one red. So we'll underline it in red so that you know. All right, but let's count by twos on this graph. So 2, 4, 6, 8, 10, 12. So this is my y-intercept. So I'm going to make my point right here at 12. And then my slope is a negative slope, and it's -1 is my slope, right? So I'm going to go down by 1 and over to the right by 1. Down by 1, over to the right by 1. Okay, and that's going to give me enough information to draw my line. Make sure you always draw your line through the entire graph. All right, so just don't draw your line through those 3 points. Make sure you draw it through the entire graph so that you have something that extends long enough that you will hopefully have an intersection. So you want to make sure it extends through your whole graph. So that's my line. All right, and now I'm going to draw the other line, x minus 6. Oops, sorry. I'm going to draw x minus 6. So I got to go down to -6. So again, I'm counting by twos. So 2, 4, 6. Make my point. And I have a positive slope of 1. So I'm just going to go up by 1, over by 1, up by 1, up by 1, over by 1, up by 1, over by 1. And I'm going to, that's going to give me enough information here to draw my other line. And again, make sure you draw it through or just enough to make it through your graph. And we can see where it intersects. Right, and that intersection there is going to be where my points are. So I would say I was counting by twos, right? So it's 2, 4, 6, 8, 9, right? Because it's halfway. And I go up by 2, 3. So my solution would be 9, 3. Okay, the location of where they intersect is my solution.
That was a lot.
That was what?
A lot.
Yes. Systems of equations are not easy. I will remind you guys that we just tried to do this in about a little bit over an hour. This is like 3 weeks of the 10th grade. So just gonna put that out there. Okay, I'm gonna do another example because we do have a little more time. So let's do another example. So I'm not just leaving you with that one-off example of how to do this. Let's see. Let's try this one up here. So we're going to do the same things, right? We're going to make sure that we have two equations that are in the y equals mx plus b form. This first one is already in that form, so I don't have to change it. So this one is good. I can just leave this one the way it is, right? This one is cool. It's good. I can leave that one, but this other one, I need to add the 4x to both sides and then divide everything by 2 because there's a 2 in front of that y, right? So it's going to become y is equal to 2x minus 11 because I divided everything by 2. And my other equation is just y is equal to x minus 3. Gonna scroll down here so I can get my graph in the picture. I'm gonna rewrite my equations so that they're not interfering with my graph. Y equals 2x minus 11 and y equals x minus 3. Okay, and now I'm going to graph them. So I'm going to graph this first one in blue. Don't erase it. Underline it. Okay. I'm going to draw this first one in blue. So I'm going to go down 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. It's a little bit off my graph. That's okay. And my slope is 2, right? So I'm going to go up by 2, 1, 2, and over to the right by 1, up by 2, over to the right by 1. So that's going to be enough again for me to graph that line that goes through my entire graph. So I'm going to start at the back here and then go up in the same direction. Make sure I keep my line on my points. Okay. There's my graph. I'm going to do the same thing with this other one. I'm just going to keep it red. So I'm going to count down to -3. 1, 2, 3. That's my first point. My first point, 1, 2, 3, -3. And my slope is 1. So go up by 1, over by 1, up by 1, over by 1. And that's going to be, again, enough for me to graph my line. I'm going to start back here and graph this line. And we can see that they don't intersect until I make them intersect because they're not great. Okay. So they intersect a little bit off of my graph. But my solution could still be figured out. I'll just count over, like I say, what, by 2 or so? Maybe that's like 12. And I know that the height is 8. So yeah, that's how you would do that. Hopefully both of your answers will be on your graph next time. But I would just say that where they intersect is 12, 8. It's actually 12, 9. And you can always check your answer by making sure it works. When you plug 12 into your equation for both of these, you should get the same answer. In this case, I don't, right? I don't get the same answer. So it's probably not correct, but they're not on the graph. So I had to kind of guess as to where they actually intersect, but where they intersect is supposed to be your answer. If they don't intersect, so it might happen that you get 2 lines that have the same slope. If they don't intersect, that means that there's no solution. And you'll know that if they have the same slope. If they have the same slope, they won't intersect. So that's no solution. Okay, that also happens as well. If you get 2 lines that have the same slope, you don't have to graph them because they're never going to intersect. Same slopes means that they will not intersect. That means no solution. Okay, no solution if they don't intersect. You could have also, you can have no solution, right? One solution, which is what you're looking for. Or you can have infinite solutions. What's a situation in which I would have infinite solutions? What do you think that even means? Infinite solutions. What does that bring to your mind? Infinite. Never ending, right? So infinite solutions means that they are the exact same line. So when you rearrange it, you figure out that they're the same line. If they're the same line, then they have infinite solutions. They're always touching. They always intersect because they're the same. All right. So infinite solutions, same line. No solution means that they have the same slope, so they never intersect. And then one solution is your goal, right? So they have different slopes, so at some point they will intersect. All right, so we did that very quickly. That was a very quick review of all of those things. This stuff is available in your folder. Check it out, try it, go on Khan Academy, do some exercises there. You can also do exercises on iExcel. You're searching for the same topics, we can work through those. All right. What are we taking a look at on Thursday to prepare you for your test on Friday?
We can do ratios, rates, and proportions on
Okay.
Thursday.
All right, that sounds good. All right. Good job so far. Keep looking over things you need to look over. Let me know if that plan changes for Thursday, but I'm sure you'll be great. We're on a good path. 2 more tests left. We can do it.
Yeah, and then I'm done.
We're gonna do it. We're gonna do it. We're gonna do it. Have you scheduled yet, Stacy?
No, I was actually trying to schedule it today, but I need the voucher.
Okay. Have you contacted Miss Butler?
No, I was going to email her after this
Okay.
class.
Yeah. Go ahead and she usually gets right back to you. So yeah, try her right after this class, and you should be good to go. All right. I will see you all on Thursday.
Okay, see you Thursday.
See you Thursday.